All right, little childrens, so we're adding and subtracting rational expressions. Believe it or not, we just did multiplication division. Addition and subtraction is tougher. And I'm not saying it to upset you or worry you, it's tougher. Because, you may remember from elementary school, you gotta have common denominator. Common denominator with fractions was a bit of a chore. Common denominator with algebraic fractions is a bit of a chore. Let me remind you that if you already have a common denominator, then you just keep the denominator, just keep the denominator and work with the numerators. In this case, 3 plus 2 is 5. You probably know that 3/8 plus 2/8 is 5/8. And 1/5 plus 1/5, you keep the denominator, you add the numerators, and you get 2/5. Now, if we could have reduced those fractions, we would have, but in those cases we didn't. That's addition, this is subtraction. And so we keep the denominator, work with the numerators. 3 minus 1 is 2. That will reduce because both those divide by 2, and so you have 1/2. That's if you had common denominator. You keep the denominator, work with the numerators. What happened though when you did not already have a common denominator? Well, you had to find it. And you know, in your little elementary school brain, looking at a 4 and your 3, and you're saying, what's the least common denominator? You're like, I don't know. I will remind you that least common denominator is the same thing as least common multiple. Because I remember in 5th grade learning about least common multiple. But what's the smallest number that 4 and 3 will both go into evenly? And the answer to that question is 12. Small thing they both go into evenly. So when we look at this, we go, well, what do we multiply by to get from here to here? This denominator 4 has to be multiplied by 3 to become 12. So 1, the numerator, times 3 is 3. What do you multiply to get from here to here? Well, you'd have to multiply by 4. So 1 times 4 is 4. Therefore, you keep the 12, now that we have a common denominator, and work with the numerator. 7 twelves, done. Yeah. In this question, least common denominator, or least common multiple for 12 and 18. Well, you know, this is how my mind works at least. You got 12, 24, 36, 48, so on. And you got 18, 36, 54, and I see my connector right there. It's 36. 36 is the smallest number that they'll both go into evenly. So what do I have to multiply by to get from here to here? I'll multiply by 3. So 15 times 3, 5 times 3 is 15. Get the answer right. What do I multiply to get from here to here? Denominator is 18 times 2. So 7 times 2 is 14. Once I get my common denominator, then I have 36 as my common denominator, and I add my numerators, I get 29. Now, if you have one of them super duper high calculators at home, you could put it in a calculator. But we can't put this algebra in a calculator. I mean, just, you know, so we're learning how, or reminding ourselves how we did it in arithmetic so we can apply it to algebra. So this case, they're going to ask us, what's the least common multiple of these fractions, or these algebraic expressions, these polynomials? Let me just for a second not talk about the numbers, because you've dealt with the numbers before. We'll deal with them when we get to one. I don't want to deal with 15, 16, 20 right now. So let's not talk about those, because we will. Let's just talk about the variables, the algebraic parts. Least common multiple. And remember, we said this before, but least common multiple, we asked the question, where is it found the most? Which is kind of strange, because we're dealing with least. Least common multiple, where is it found the most? But that's how this works. So look at the A. Do they have an A in common? Oh, we're not doing common. Least common multiple. Where's A found the most? AQ. Where's B found the most? B to the 5th. Where's C found the most? C to the 6th. So whatever number goes here for the 15, 16, and 20, then that's going to be your least common multiple. See? I got the ABC right, and then the number, whatever that was. Now, Let's talk about the least common multiple for real algebraic stuff, non-monomial stuff. We don't know the smallest thing that they'll both go into evenly. We're gonna have to factor them, because right now they're not in good factored form. So let's factor this. This one, there's a GCF. It's gonna take work. This is work, and you may have watched this video a couple times, because I'm gonna go quick, and we're not gonna get a ton of examples, but you may wanna go back and re-watch it to pick up what's going on. But your GCF here is X. So you gotta get your factors so you can see what's going on. So that's X squared minus X minus 2. And then that'll factor because the leading coefficient is 1. So it's double bubble, X and X, signs are different. Factors of 2, whose difference is 1, and it would be 1 and 2. So hold on to that thought. That's what that is right there. Now let's look at this other one over here, where you've got, it's actually a perfect square. That's fine. You can see it that way, or you can see it as a leading coefficient 1. Signs are the same, both minus, factors of 4, whose sum is 4, 2. Okay, now looking at the least common multiple. It's got to have an X in it. X is only found one time. X by itself, only found one time. Put a little check mark there because I've dealt with it. X plus 1, where's it found the most? One time. Little check mark. X minus 2, where's it found the most? One time here, 2 times here, so 2 times. And I can either write the X minus 2 squared, or I can write X minus 2 times X minus 2. That's the least common multiple for those two polynomials. X times quantity X plus 1 times the quantity X minus 2 squared. And that's what they got. That's what it is. So that's going to take some practice. You're going to go back and be reminded of some skills. And so that's how that's going to need to work. Let me, we could do those too, but let's actually do some problems here, because you've got to get these skills. You're going to need them. You're going to have them. So if we're going to add fractions, what do we have to have? Common denominator. We've got to have a common denominator. We're going to add fractions. So if we're going to add these two fractions, we got to know the least common denominator or the least common multiple. It's the same thing. So you got to know what's the smallest number that 6 and 14 will both go into evenly. Thinking 42. If you don't know how to do that, I suggest you review your algebra. 42 is the smallest number that 6 and 14 will both go into evenly. Then look at the ABs, right? Where's B found the most? B squared. Where's A found the most? A squared. And those are the common denominators, the least common denominator, least common multiple. So we go back then, because we want these to be equivalent fractions, how we did it in Algebra 1. We're like, well, what do we multiply by to get from the 6b to that? We multiplied by 7a squared b. Look at it, think about it, look at it, think about it. We'd have to multiply the 6b times 7a squared b to turn it into this. So that's what we got to do to that. So that's going to be 35, a to the 4th, b. If you reduce this fraction, like the old way of reducing fractions, we dealt with it in Algebra 1. This would reduce, because they both divide by 7. This would reduce. It'd be a to the 2nd in the top. And this would reduce. It'd be b to the 1st in the bottom. Because they're the same. You could always go back and look and see, make sure it would work that way. All right, going along a little further. How do we get from here to here? What would you do to that denominator to turn it into that one? Well, you'd have to multiply the number by 3, the 14 by 3. The a squared is already there, and the b squared is already there. So just 3. So that makes that 27. 9 times 3 is 27. Now that you have a common denominator, then you keep the denominator, and you work with the numerator. So it'd be 35, a to the 4th, b, plus 27. And that's the answer. Pretty sure. that's too fast, back it up and watch it over. So I could do more of these and talk to you about more of these, but I want to do more fun stuff, like real algebra with polynomials, not just monomials, but binomials anyway. So we're going to subtract this one, which is going to be even worse because it's the negatives in your life that cause you the most trouble. And so before we can even talk about what the least common multiples are, or least common denominator is, you have to do factoring. You got to factor. You have to simplify this mess. So there's a common denominator of 3 in the first denominator. I mean a common factor of 3. Common factor of 3 in this one. Common factor of 6 in this one. So I'm going to do this straight up. There's a, being that I've been here before, I see something, but I'm going to pretend I don't see it, and I'm going to go straight for what I'm going to do. So least common multiple least common multiple for these two fractions. Least common denominator. So look at the number, the 3 and the 6. What's the smallest thing that 3 and 6 will both go into evenly? 6. Where's the x minus 5 found the most? One time. One time here, one time here. So one time here. And that's how that works. That's how you find the least common denominator for rational expressions. Now that we have that, we say, well, what do we multiply by to get from here to here? Just a 2. So that would be 2x plus 20. What do we multiply to get from here to here? 1. Nothing really changed, so nothing really changes. So I'm just going to redistribute that 3. So I probably shouldn't have factored it to start with, but I saw something, so that's my me. I could have canceled or reduced these, and it would have made the denominator a little bit smaller, but I didn't tell you that, so don't look at it. So to carry on, once we get our common denominator, we keep the denominator and work with the numerators. Now remember, it's the negatives in your life causes the most trouble, so the danger with this one is to mess this up. So you got, I'm just going to write the whole thing. You've got the 2x plus 20 minus 3x minus 15. Somebody said, well, why? I thought there was a plus 15. You got to distribute the negative. It's like that's in parentheses, minus the whole thing. So you got to distribute the negative to both of them. Once you get that done, then you can do like terms to get negative x plus 5. You see those, the like terms? That one and that one. That one and that one. See that? You may see anything else. Look at that and that. What are they? They're opposites. That's negative x, that's positive. That's positive 5, that's negative. They're opposites, which means they cancel, and you get a negative 1/6. Cute. Negative 1/6. So this will be the last one of these that I do. This video is probably long enough already. Let me look. I'll make this one the last one. I started picking one of those others, but so I'm going to need to add fractions, so I've got to have a common denominator, but I see that first denominator is not factored, so I got to factor it so that I can include everybody. Where's it found the most, and know what the answer to that is. So it's easy kinds of equals. It's 1. There's no GCF. It's not a special case. Double x and x signs are the same. They're both plus. Factors of 18 whose sum is 9 would be 3 and 6. So where is x plus 3 found the most? One time. So each of the common denominator is gonna have an x plus 3. Where's x plus 6 found the most? One time. So the denominators have x plus 6 in the common denominator. So that's the least common denominator for those two fractions. So I'm looking at it and I go, well, what changed from here to here? Nothing. So nothing changes with the numerator. Those are equivalent fractions. What changed from here to here? Well, I multiply by x plus 3 to turn that into that. Multiply by x plus 3. If I'm going to multiply the denominator by x plus 3, I got to multiply the numerator by x plus 3. Let me just make a little note of that, x plus 3. And so I can see that's 5x plus 15. It's distributive property, right, with the 5. And so then I come to the end of the journey here. I think it's the end of the journey. And I put these together. It is addition, so that makes it easier because I don't have to change the signs. I see the 4x and the 5x is 9x plus the 15. Now, if I could take out that 3 right there, and it would come out, it was a GCF of 3. If I could take out that 3 and have it reduced with something here, that'd be great. It just doesn't. But I need to be aware of those kinds of things because they are possible in the grand scheme of things.